What's happening? So today is pretty exciting. Loto Instruments sent in this 100 megahertz USB scope. This is the OSCH02. It's got two input channels and it's got this little plug here, which you can have these accessories. They sent this one in too. It's an isolated differential input. The only thing with this one is it only goes up to 300 kilohertz. So not going to work for switching power supplies, but maybe for input line stuff or motors or something like that. So this guy was free. I'll have to go easy on him, but figured we'd hook it up and see what it can do. Came with this USB cable and a couple of scope probes. So these go for about 240 bucks on AliExpress right now, just for this base unit. So I think we'll just hook it up to the function generator for a quick test and we can see how the software works. So to get the software, we have to go to lotoinst.com, which loads surprisingly slow for whatever reason. We can change it to English. And now downloads software. And this one is a link to a Google Drive. So put that on another tab. You get this. Here's my folder with, this is the Google Drive file here. So you need Win7-zip to unrar it. And then in here, there's software and drivers. So if you have Windows 10, it looks like you don't really need the drivers, but this one's the H02. And then you got to get this, unrar this oscilloscope for Windows. And then in here, it's this OSCH02.exe. So that starts full screen. I'm only recording part of my screen, so it's kind of a funny little program here. It has this thing, but I can't seem to change the size of the window for whatever reason. But you can start the device, and here's the waveform. This 1 kilohertz sine wave. You can adjust these knobs. Alright, I'll go up the frequency and make a square wave and see what it looks like. Alright, so here it is at 15 megahertz square wave, so see what we can find here. So I checked that on my other scope and it just kind of looked like a sine wave on that one too, so I changed it down to, I think 1 megahertz is about as good as this function generator will do for a square wave. So you can see it's wobbling a tiny bit. So we can check it out on the Rode-Schwarz scope here. So this is what it looks like. This is just doing a screenshot, but it is a little bit more steady on this one. Alright, so I've dialed it back to 100 hertz and 2 volts peak to peak to get a super clean signal. And what I want to do is write some Python code to control the scope. So I reached out to Loto Instruments and they were nice enough to send me some example code for their API in Python. So I've modified it slightly. The first thing was it was written in an old Python 32-bit, so I had to convert it to 64. And I also added in matplotlib so we could view the waveform in a plot. And the other thing was all the comments were in Chinese, so I translated those. And you can see going through here, you also have to get the DLL. It was referencing a 32-bit DLL, so I got the 64-bit one just from their install directory for the program. So if you look through here, they have the first step. They have this pretty well labeled with different steps. So setting the oscilloscope to number 7, That's where you select which model of the oscilloscope you have. 7 is this one that I have, the O2. And then you're turning on the device, getting the first address of the data buffer, and setting the buffer to 128 kilobytes. Let's see what I got here. Setting the channel input range for A and B. Setting the coupling, trigger mode, rising edge, start the acquisition, wait 200 milliseconds, check if it's complete, and this here is where we get the data and put it in some arrays. So these guys here I've added in doing a little calculation. So the time array here is just the iterator divided by the sampling frequency, and then this channel A and B are calculated with 10 volts, so that's the range. So we're going -5 to +5, so that's 10 volts times the value, and the value that's read is 0 to 55 number from the 8-bit A to D converter, ADC. So we're subtracting 128 because 0 volts is 128, and then dividing by 256 because that's how many bits. So then we do the matplotlib stuff here where it creates the plot and sets the range from -5 to +5. Then turn everything off and close it. So we can run that. Oops, we have to remember to turn this guy off first. The connection fails, so we can run that. Okay, I think we have to close the program completely. Okay, I gotta change this title here too. There we go. So here it is. You can see it's a little bit funky here on the beginning and the end, and it's not quite centered on 0 either. It's a little bit offset, and I think it's scaled slightly wrong too, so it doesn't quite match up as well as their software does. So I guess it needs a little more tweaking. They also have this manual that has a bunch of info, so this is where you can look up the different bits and stuff to set for the different settings, the different device numbers and all that stuff. So one thing I might work on in the future is translating this to English, but you can gather most of what to do without even worrying about the Chinese stuff, because all the numbers and everything and all the functions are in English, I guess. So it's not that long, actually. It's only 12 pages. So I went ahead and created a GitHub for this project. It's github.com/circuitanalysis/Loto. And I uploaded the files here. So there's the DLL files, there's the manual, and this capture waveforms.py is the one that we were just looking at. So you can play around with this here, and maybe in the future I'll work on translating some stuff or adding some more things, or if anyone wants to help out with that, you know, feel free. And also feel free to post in the comments if you're using this and you want to collaborate on developing any of this stuff. So that's it for today. If you guys have any other USB scopes you like or use, let me know in the comments. I've got a Handtech and an OON as well that I might make some videos on in the future, so let me know if you're interested in that. And thanks for watching. I'll see you next time.